Good evening. I'm Spot On Weather meteorologist Matthew Euler, and tonight we're going to do a Spot On Weather lesson titled Thunderstorms, Nature's Fireworks. What are we going to talk about in tonight's lesson? We are going to talk about the causes of thunderstorms, the stages of development, the anatomy of a thunderstorm, the weather elements associated with thunderstorms, and then the climatology. We will also take a look at hail and the climatology of hail in this presentation. So let's get right to it. Thunderstorms, a very common warm season occurrence across the middle latitudes, even more common across the tropical latitudes. So let's get right to it and jump right into the lesson. So the first thing I'm going to talk about is what causes thunderstorms? Well, there are three main factors. And these factors are moisture. You need a lot of moisture in the low levels of the atmosphere. You need instability, which is basically a situation in which air is going to want to rise or is positively buoyant. And then you also need some sort of lifting mechanism. You need some kind of lifting mechanism to get that warm, moist air aloft. And then basically, with warm, moist, unstable air, as it rises, quite often in the summer season, that usually happens during the maximum heating time of the day. That's usually late afternoon or early evening. A lifting mechanism is needed, such as a front, a dry line, land-sea breeze interaction, if you're along a coastline, and mountainous terrain. And then usually, when we talk about frontal systems, we talk about air masses that are moving from one side of the front to the other, mainly the cold air, the continental polar air, or possibly a dry, hot continental tropical air mass is moving into a warmer, moist, unstable maritime tropical air mass right out ahead of the front. So these are some of the major causes of thunderstorms, some of the scenarios that play out for thunderstorms to develop. In this picture here, a really nice picture showing you a thunderstorm cloud. This is the thunderstorm top forming that common anvil that we typically see. All right, so let's first talk about heating of an unstable air mass. This typically occurs during the summer months. You have a very high sun angle. This first step here indicates that it sends its shortwave solar radiation down towards the Earth's surface. It heats this land area. And as air is heated here closer to the surface, it becomes less dense and it wants to rise. And then as it rises, air rises, it cools and condenses to form clouds. And usually these are the formation of the puffy or cumulus clouds. Once these cumulus clouds form, this updraft can continue to rise, resulting in taller clouds known as towering cumulus, and then they grow into what's known as cumulonimbus clouds, or thunderstorm clouds, and they produce your lightning and thunder. And this is just from the heating of the sun, heating the Earth's surface. You have a warm, moist, maritime tropical air mass in the lower layers of the atmosphere, and that air wants to be buoyant and wants to rise. Various lifting mechanisms are also needed for thunderstorms to develop. This could be a frontal boundary, and in this diagram here, I'm showing cold, advancing air which is much denser and heavier, and it wants to remain closer to the ground because of that greater density. As it moves into a warmer, moist air mass, this warm air is going to be lifted out ahead of the cold front off the ground and form thunderstorms out ahead of the cold front. Another method of lifting is orographics, where you have a mountainous terrain. And this can happen, thunderstorms can happen in the vicinity of mountains in two ways. As wind blows against the windward side of the mountain, the wind is not allowed to go through the mountain, but it has to go up and over the top of the mountain. And as that air rises, it cools and condenses and forms clouds, thunderstorms on the windward side, and dumps the precip on that side. In addition, the sun usually heats the slopes much quicker than the valleys below during the summertime, as when that sun is much stronger, that causes airs to rise up over the mountain slopes, and the valley air comes in beneath it as cooler, denser air, and that can also form thunderstorms. A third method of lifting is dry lines, what's known as a dry line, and this typically happens down here in Texas, where you get a continental, very dry air mass, continental tropical air, which basically is, as a drier air mass, is heavier than this maritime tropical air with southeast wind flow out of the Gulf of Mexico. So you get this continental tropical air, very dry, running in along this boundary known as a dry line. This dry line is moving into a warm, moist, unstable air mass, usually maritime tropical air, and that a lot of times is enough to kick off thunderstorm development. And then land and sea breeze interaction. So what happens during the day is the sun, it does not heat the water at the same rate it heats the land. Instead, the sun's shortwave radiation heats the land much quicker than the water, and that causes the air to rise because it's less dense over the land, and you get a circulation where the wind is blowing in from the water towards the land, and this is known as a sea breeze. This typically happens a lot down in Florida as well as the Gulf Coast states. All right, so now we move into the stages of development of thunderstorms. There are three main stages of development. There's the cumulus stage, the mature stage, and then the dissipating stage. And then, so I'm showing you a picture of the various height levels in the atmosphere. I'm showing you the cloud growth in the vertical in each diagram here. I'm showing you these yellow arrows, which represent your updrafts, and then when they're pointed downward, that's the downdrafts. So you have, with the cumulus stage, this is the initial stages of a cumulus cloud. This is when it becomes transitioning from a cumulus to a towering cumulus. It's got a little vertical, it's got some greater vertical height at this point. Not enough, though, to produce rain. It's dominated primarily by updrafts. Now, as this system and this cloud continues to grow vertically, it can be quite tall in height, sometimes as tall as 60,000 to 70,000 feet. And what happens is it becomes the mature stage in which we now have both an updraft and a downdraft cell in the thunderstorm cloud itself. And then you've got this rain that comes down, starts falling, and you get lightning and thunder and all that. And as this air comes down, this cooler air with the rain gets dragged down from aloft. This is known as a downdraft. And then you have the dissipating stage. And this is where the thunderstorm cell is pretty much dominated by downdrafts only. All right, and this is when the storm pretty much rains itself out, and the process can again start once more if the conditions are unstable. Now, this is an example of the anatomy of thunderstorm. This is a really neat picture. This is an example of an extreme type of thunderstorm known as a supercell, and these little spirally red arrows indicate tilted updrafts. So you have these updrafts on this side of the thunderstorm. You got, as the thunderstorm grows taller, if it grows tall enough up to about 60, 70,000 feet, you can sometimes get what's known as overshooting tops over the tops. If these updrafts are strong enough, they basically break through a lid. That lid is typically known as an inversion in the atmosphere. An inversion is an area where those temperatures increase with height. In a very stable situation, typically it's a tropopause up here above the top of the thunderstorm. That usually flattens things into an anvil shape. However, in this case, with a very strong updraft, it has enough momentum to punch through the tropopause, and that results in these overshooting tops. This is indicative of a very intense, severe thunderstorm. This is a supercell. There's downdrafts on the other side of the cell. Here's your sequence of events as far as what you would see if you were on the ground. Supercells can also be responsible for producing tornadoes, especially in the Central Plains states. So I just wanted to show you generally what you have in a thunderstorm, these updrafts and then downdrafts. Okay, and sometimes these updrafts can be rotating, and that's known as a mesocyclone. But not all thunderstorms are supercells. All right, what are the weather elements produced by these thunderstorms? Well, you do have lightning, which we're very familiar with as we watch thunderstorms come in. And this is produced by the charge difference between the positively charged ice crystals at the top of the cloud and the negatively charged water droplets in the lower portion of the cloud. So a positive negative charge, you get this electropotential, or this difference in electricity between the positive and negative charges of the cloud. Eventually it becomes enough to overcome the air resistance, and you get a lightning bolt. You can get a lightning bolt from within the cloud to cloud. You can get a lightning bolt from cloud to the ground. Directly beneath the cloud, you typically have what's known as a shadow, and you have a negative charge in the lower part of the cloud, and then the opposite charge, especially on the ground, directly beneath the cloud, or on taller objects. That's why they say you never want to be the tallest object, because that positive charge will literally travel up to your head if you're the tallest object during when you have thunderstorms in the area. And that you can actually attract that lightning from cloud to the ground. But actually, lightning travels from an object on the ground up towards the base of the thunderstorm because of this. Something else we're very familiar with is thunder, which is produced basically by the expansive heating of the air column. That air column can heat up to as much as 50,000 degrees Fahrenheit, 5 times the temperature of the surface of the sun. That's really impressive. So this heated column of air is lit up and expands really rapidly and creates a sound known as thunder. Additionally, thunderstorms can produce what is known as straight line winds when you have colder downdraft winds descending out of the cloud base and they spread out horizontally along the surface. This is usually what happens as a thunderstorm line approaches your area. You get this downdraft colder winds, and you actually can feel that. You'll feel a drop in the temperature as that thunderstorm approaches, also known as outflow. And then heavy rain. The heaviest rain typically occurs in conjunction with the greatest frequency of lightning. So if you're getting a lot of lightning, you're typically around the area with the heaviest rain. Research has shown this. And that can result, obviously, the heavy rain and flash flooding with extreme amounts of rain in short periods of time. And then hail in more severe cases. This is caused by the path a water droplet takes. So as it rises up, the water droplet on these updrafts, these upward rising motion of currents of air in the thunderstorm, it rises towards colder portions of the thunderstorm and freezes. And then there's a downdraft that will take that, and basically it'll recycle up again to the upper portion of the cloud, and it'll accrete additional layers of ice, and then it basically will, when it gets heavy enough, fall to the ground. Here is some thunderstorm climatology. The greatest number of thunderstorm days is typically along the Florida peninsula and into the Gulf Coast states, where you can have in Florida over 100 thunderstorm days a year. A thunderstorm day is basically a day in which thunder is heard at some point. And then, of course, in the Central Plains states, that's another hot spot, 50 plus days of thunderstorms. Much less as you get up towards the Northern Plains states, 30 to 40 thunderstorm days on average per year. And then you notice the West Coast hardly has any thunderstorm days because of the stability of the fact there's a colder ocean current off the coast, and they're also on the stable side of the Eastern Pacific high pressure system. Hail climatology. Look at how big these hailstones can grow. This is a person holding these large hailstones in Argentina. Generally, the hail frequency is greatest over the Central Plains states, Oklahoma, Kansas, and into Colorado. All right, that wraps things up tonight on our lesson, Thunderstorms. We certainly hope you enjoyed this presentation. Spot on weather. If we're not spot on, we're not doing it right. Have a great evening, everyone.